Let us see 10th Science Unit 3 Thermal Physics Book Back Exercises. Roman letter 1. Choose the correct answer. Question number 1. The value of universal gas constant. Options. A. 3.81 Joule mole per minus 1 Kelvin per minus 1. B. 8.03 Joule mole per minus 1 Kelvin per minus 1. C. 1.38 Joule mole per minus 1 Kelvin per minus 1. D. 8.31 Joule mole per minus 1 Kelvin per minus 1. The correct answer is option D. 8.31 Joule mole per minus 1 Kelvin per minus 1. Second question. If a substance is heated or cooled, the change in mass of that substance is options A positive, B negative, C 0, D none of the above. The correct answer is option C 0. Third question. If a substance is heated or cooled, the linear expansion occurs along the axis of options A x or minus x, B y or minus y, C both A and B, D A or B. The correct answer is option A x or minus x. Question number 4. Temperature is the average dash of the molecules of a substance. Options A. Difference in kinetic energy and potential energy. B. Sum of potential energy and kinetic energy. C. Difference in total energy and potential energy. D. Difference in kinetic energy and total energy. The correct answer is option C. Difference in total energy and potential energy. Fifth question. In the given diagram, the possible directions of heat energy transformation is. These are the options. The correct option is option A. Fill in the blanks. Question number 1. The value of Avogadro number 6.023 into 10 to the power 23 mole per minus 1. Question number 2. The temperature and heat are dash quantities. Answer scalar. Third question. 1 calorie is the amount of heat energy required to rise the temperature of dash of water through dash. Answer 1 gram of water through 1 degree Celsius. Question number 4. According to Boyle's law, the shape of the graph between pressure and reciprocal of volume is dash. Answer straight line. Roman letter 3. State whether the following statements are true or false. If false, explain why. Question number 1. For a given heat in liquid, the apparent expansion is more than that of real expansion. Answer false. The correct statement is, for a given heat in liquid, the real expansion is more than that of apparent expansion. Question number 2. The thermal energy always flows from a system at higher temperature to a system at lower temperature. Answer true. Third question. According to Charles' law, at constant pressure, the temperature is inversely proportional to volume. Answer false. The correct statement is, according to Charles' law, at constant pressure, the temperature is directly proportional to volume. Match the following. Linear expansion. Answer change in length. Superficial expansion. Answer change in area. Cubical expansion. Answer change in volume. Heat transformation. Answer hot body to cold body. Boltzmann constant. Answer 1.381 into 10 to the power minus 23 Joule Kelvin per minus 1. Assertion and reason type questions. Question number 1. Assertion. There is no effects on other end when one end of the rod is only heated. Reason. Heat always flows from a region of lower temperature to higher temperature of the rod. The answer is option C. Assertion is true, but the reason is false. Question number 2. Assertion. Gas is highly compressible than solid and liquid. Reason. Interatomic or intermolecular distance in the gas is comparably high. Answer. Both the assertion and the reason are true, and the reason is the correct explanation of the assertion. Roman letter 6. Answer in briefly. Question number 1. Define 1 calorie. It is in page number 34. 1 calorie is defined as the amount of heat energy required to rise the temperature of 1 gram of water through 1 degree Celsius. Question number 2. Distinguish between linear, aerial and superficial expansion. Linear expansion, cubical expansion, superficial expansion. Linear expansion, when a body is heated or cooled, the length of the body changes due to change in its temperature. Cubical expansion, if there is an increase in volume of a solid body due to heating, it's called as cubical expansion. Superficial expansion, if there is an increase in the area of a solid object due to heating, then the expansion is called superficial expansion. Linear expansion, the ratio of increase in the length of the body per degree rise in temperature to its unit length. The ratio of increase in the volume of the body per degree rise in temperature to its unit volume is called a coefficient of cubical expansion. The ratio of increase in the area of the body per degree rise in temperature to its unit area is called a coefficient of superficial expansion. Question number 3. What is coefficient of cubical expansion? It is on page number 35. The ratio of increase in volume of the body per degree rise in temperature to its unit volume is called as coefficient of cubical expansion. This is also measured in Kelvin per minus 1. Question number 4. State Boyle's law. It is in page number 36. When the temperature of a gas is kept constant, the volume of a fixed mass of a gas is inversely proportional to its pressure. P directly proportional to 1 by V. Fifth question, state the law of volume. It is in page number 37. When the pressure of a gas is kept constant, the volume of a gas is directly proportional to the temperature of the gas. V directly proportional to T or V by T is equal to constant. Sixth question, distinguish between ideal and real gas. Ideal gas, real gas. Ideal gas, if the atoms or molecules of a gas do not interact with each other, then it is called as an ideal or perfect gas. Real gas, if the atoms or molecules of a gases interact with each other with a definite amount of intermolecular or interatomic force, then it is called as real gas. Ideal gas, at very high temperature or low pressure, a real gas behaves as an ideal gas because there is no interatomic or intermolecular force of attraction. Real gas, at very high temperature or low pressure, the interatomic or intermolecular forces of attraction are weak in an ideal gas. Seventh question, what is coefficient of real expansion? It is on page number 36. Coefficient of real expansion is defined as the ratio of the true rise in the volume of the liquid per degree rise in temperature to its unit volume. The SI unit of coefficient of real expansion is Kelvin per minus 1. Eighth question, what is coefficient of apparent expansion? It is also in the page number 36. Coefficient of apparent expansion is defined as the ratio of the apparent rise in the volume of the liquid per degree rise in temperature to its unit volume. The SI unit of coefficient of apparent expansion is Kelvin per minus 1. Answer in detail question number 1. Derive the ideal gas equation. It is in page number 37. You have to write from ideal gas equation is an equation to describe the state of any gas. Question number 2. Explain the experiment of measuring the real and apparent expansion of a liquid with a neat diagram. It is in page number 36. You have to write 3.32.